All right, hello. So here we are. We're at lesson 6BB, comparing slope. So remember, slope is change in y over change in x. And in y equals mx plus b, remember we see the slope showing up in front of the x. So you might want to highlight that part because today we're comparing slope. So we want to make sure that you can find slope and you know which one is changing faster than the other. So today you're going to be identifying unit rate, initial value, and the equation, if applicable, for each represented case below. All right, so I'm going to zoom in. Hopefully you got the change in y over change in x. If you need to, remember you can reference, ooh, that's super zoomed in, reference page 27 that we filled in just yesterday, rate of change, so that you can see how to find it from a graph, from a table, from an equation, or from a word problem. But today we're going to be focused on lesson 6BB and using the examples that are here. So let's look at this very first one. We have a graph and we have an equation. So in my opinion, the equation is going to be much easier because you look for what's next to a variable. And so here we have a equals 75 plus 2 over 3d. So whatever those are standing for, I know that 20 over 3 is next to a variable. So that tells me that's how it's changing per whatever the day represents. So it looks like they started at 75 and then they're going up 20 over 3 every d. Maybe that's d for day. But we see that that's the equation's slope. So the slope here is going to be 20 over 3. But that's a hard number to compare. So let's think about that. How many 3's could I take out of 20? Well, I could take out 6 and I would have 2 left over. So that could be written as 6 2/3. Well, let's look over here now to the graph. So the graph looks like it starts at 90, and maybe that's where they got their letters. See the A here? A is for amount saved in dollars, and D is days, number of days. So this tells me on the equation they started with 75, and then they saved $20 every 3 days, or 6 2/3 each day. So that's what that tells me there. But in this case, they started at 90. So let's go ahead and write an equation here. A would equal 90. They started with 90. It looks like they added from there because their account is going up. So I'm going to write plus. They started with 90, and then they're going to add a certain amount. Now, these are really hard to see little points on here. They're very faint lines. But let's see if we can see any good points. So on this, I at least see a good point right here. And so I'm going to go ahead and write down these 2 points. So from here to here is what I'm going to look at because that's really the only one I can see really clearly. So I'm going to put a little table of values to the side here where D is X and A is Y. You could always title that X and Y if you'd like to, if you're more comfortable with that. But here we see that for days 0 days, they have $90. So for 0 days, they have $90. And this looks like it lines up right here with 8. So always look at what it's lining up with. Notice they don't go by 1s. They went by 2s here. So make sure you know what it's lining up with. That's lining up with 8 days. So after 8 days, they had $120. All right, so now that it's in a table, it's a little bit easier to see. From 90 to 120, looks like they added 30. And so there's our change in y. So our change in y was 30 over our change in x. Looks like from 0 to 8, they added 8. So they added $30 for 8 days. Well, that's something I can reduce. So let's go ahead and reduce that at least by 2. Reduce by 2. And that means I would have $15 in 4 days. Now, I can't reduce that anymore, so this equation would be 15 over 4 times the number of days. So they're saving $15 every 4 days. So who's saving more and who's saving more quickly? So that's what we have to compare. So this slope right here is 15 over 4. Let's write that as a mixed number. How many 4's can I take out of 15? Well, I can take out 3, and I would have 3 left over right there. So I would write that 3 3/4. So this person is saving $3 3/4 a day, so $3.75 basically each day. This person is saving $6.67 each day, and so who is saving more? Well, this is going to be the bigger slope. But let's go ahead and highlight these slopes. So for the graph, it's this. For the equation, it's that. And which one is more? Well, this one's going to be more. So this one is saving more per day. So let's just write in saving more money per day. So that's how we identify them. So as long as you know how to identify slope from a graph and from an equation, then it's easy to compare. Let's go ahead and look down here. Now I like this one because they gave us a table, and I love a good table. It makes it much easier to see. So from 7 to 19, they added 12. From 0 to 4, they added 4. And so my change in y over change in x would be 12 over 4. Well, what's that standing for? 12 liters in 4 hours. So it gained 12 liters in 4 hours, which means if I reduce that, that's going to be 3 liters per hour. So I could write it that way. So for the table, we have the slope is 3 liters per hour. What about the graph? All right, so over here on the graph, let's write an equation for this because I bet you can. I can see where it starts and where it goes. And so let's write the equation. Let's see, we've got a little bit of space above it if I zoom out a little bit. All right, so this is amount of water L per hour. So let's write the equation L equals, well, it starts with 15, and then it looks like it increases from there a certain amount each hour. All right, so let's look and see what it's increasing by. This might be nice to write as a table again. And again, you could either use the letters that are there, H for X, L for Y, or you could just use X and Y. So this point, after 0 hours, it's at 15 already. After 0 hours, so it's starting at 15, and then it's going up from there. It looks like that's a good point right here. So make sure that you're reading what that goes to. So this goes down here to 9. So after 9 hours, the level is at 25 liters after 9 hours. And so now we just do our change in y over change in x. Change in y right here from 15 to 25, it went up 10. Over the change in x, looks like it went up 9. And so if we write that as a mixed number, we would get 1 and 1/9 from this graph. So over here for our equation, we can write it as 10/9. But when we're actually writing it out, we're going to write out 1 and 1/9 so that we can compare. So the slope here, it's adding 1 1/9 liters per hour. It shows up right there in the equation. And for the table, this other bucket of water apparently is adding 3 liters per hour. So which one is adding more? Well, this one is, the one from the table. And so this one is adding, what's it doing? It's adding more liters per hour. So for every hour, this one is filling up 3 more liters. For every hour here, this one's only filling up 1 1/9. All right, let's go look at some more. Again, this is just comparing slope today. And so here we have another graph and another table. All right, so let's look at the graph first this time. This time it starts at 0, so that's nice. And it looks like it's cost in dollars for pizza slices. So that would make sense. If you didn't buy any pizza, they shouldn't be charging you anything. But let's go ahead and write this equation. So C would equal, you could say it starts at 0 and then adds from there. C equals 0 something. And so let's go ahead and figure out what they're adding. So follow this for a good point. Looks like there's a good point right there. And so I'll go ahead and fill in a table of values. We know the point 0, 0 is on there. And then this point after two slices, it costs $8. All right, well, that's an easy change in y over change in x. This one is charging $8 for 2 more slices, which means it would have been $4 per slice. So that starts at 0, then adds $4 per slice. So we could even keep the equation like that. So our slope there, our rate of change, is $4 per slice for the graph. All right, now let's look over here. So this is in a table. Remember, in a horizontal table, the top one is the x, the bottom one is the y. And so we'll set up our change in y over our change in x. And we'll look from 0 to 36. Looks like it changed by 36. That's our change in y. That's our change in cost. For how many extra pieces? Well, from there to there, it's 12 more pieces. And so if we divide 36 by 12, we get 3. All right, so whatever this pizza place is, It's cheaper because they are only charging $3 per slice of pizza. And at this one, they're charging $4. So we can circle that one. That one is greater. And we would say charging more money per slice. Charging more money per slice of pizza. All right, let's look at this one. Hopefully you're noticing it's always the same thing. Change in Y over change in X. But let's try it again down here. Here's our table. M equals, so from 8 to 28, they added 20. From 0 to 16, they added 16. And so our slope would be 20 over 16. Now I do want to reduce that to make it a little easier to see. If we reduce by 2's, we'd get 10 over 8. We could still reduce by 2 again. So let's reduce by 4's. If we reduce by 4, we would get 5 over 4, which we could see as 1 1/4. All right, so this is changing. Let's see, it's height in feet and time in seconds. So it's whatever it is, it's gaining feet every second. And so this is going to be 1 1/4 foot every second. Whatever that is, it's changing fast. Let's look at it from the table this time. Over here, we have 0, 15. So 0, 15. Again, I like to put these in a table, so we can scrunch it in over here, I guess. Let's write our little table over here. At 0, at x is 0, the height is 15. After 1 second, I can't quite read that, so let's go ahead and go over here. That's easier to read on this graph. So that's after 4 seconds. So 4 seconds goes up to 20 feet. Okay, so this one looks like the change in Y is from 15 to 20, it changed by 5. And the change in X was 4. Oh, hey, look at that. So this one changed the same amount as the other. So 5 over 4 can be rewritten as 1 1/4 again, which means these have the same change. So these are changing the same, changing the same. These are changing by the same amount each time. So what's the difference between them? Well, this one, if we were to write their equations, this one started at 15, this one started at 8. And so for this equation, we would write y equals 8 plus 5/4 x. In this one, we would have y equals 15 as the starting point plus 5/4 x. And so we see their change is the same. It's changing by going up 5 feet every 4 seconds, up 5 feet every 4 seconds. But what's different about these is their starting values. This one started at 8 feet. This one started at 15. And so no matter what, this one's always going to be higher up than this one is, whatever feet they're talking about. All right, let's flip it over. Let's look at this fun one. So it says m equals t over 3. Now, I don't know why they used m. Let's rewrite this. I'm going to scribble it out. Okay, let's write y equals x over 3. That's how you're really going to see it. So what do we do here? Well, that looks kind of funny. Just remember, in front of x, there is a 1 that we don't see. And so we could write this instead as y equals 1/3 times x. That's just a clearer way to see it. So we can already see the slope then. Our slope would be 1/3. So I'm going to highlight that so we can see it, and it shows up right there in front of the x. Now on the graph. So this graph is nice. Just like this one, it would start at 0, 0. So let's write a little table of values for the graph. Starts at 0, 0 right here. And then it looks like there's a good point even right here where x is 10 and y is 5. Make sure that you're writing it the right way. And then it's just change in y over change in x. Change in y over change in x. So from 0 to 5 went up 5. From 0 to 10 went up 10. And I can reduce, ooh, can you see that? Sorry if that's so tiny for you. We can reduce 5 over 10 into 1/2. So for the graph, our slope is 1/2. All right, so which one is more? What's more, 1/3 or 1/2? Well, 1/3 is going to be more. So what is this discussing? Miles. It looks like miles per minute. So this one will be going 1/2 a mile every minute. This one's only going 1/3 of a mile every minute. All right, very last one in this lesson. Which equation has a rate of change greater than the rate of change in the line shown? So we can't be tricked. This is not going to be the equation for this line. We just have to find each one. So if we look at it, this one's going up 1, 2, 3 over 1. This goes up 3 over 1. So which one has a rate of change more than 3? That one. The end.